Alright guys, so for this unit we're going to be talking about geological time. And when we talk about geological time and how we know how old the Earth is and what evidence is there to give us that, we need to really focus on some certain principles and some theories that we understand in geology. Now, as we go through this unit, I assume that you know the three types of rock. We have metamorphic, okay, igneous, okay, and sedimentary. All right. Now, if you don't know anything about these rocks, I would encourage you to go to the supplemental lesson that I've given you for this and review about these types of rocks because you're going to need to know them. A lot of what we do is required to understand that understanding. All right, so let's talk about geological time of the Earth. All right, so determining geological ages, we have to do this in two different ways. We have the relative age dates, and what this is when we take rocks and we place certain events in the proper sequence. Okay, so we have an order of where things happened. We don't have exact dates or times, but we do know the sequence of things that happen. You may talk about a football game, let's say, for example, and we know that they went into the huddle, they broke the huddle, they came out, ran a play, and they ran the huddle again. We know the sequence of events, but we don't know the exact date. Okay, numerical dates. This specifically gives dates. So, for example, if we went back in time and we talked about the birth of Jesus and the exact time he was born, or when the dinosaurs were on Earth, we know relative dates, we know the exact time. If we go back, we know when the president was elected, those specific dates. Those things were specific. You know your birth date. Okay, and this has a different name, and it is called absolute dating. So we have two types that we really want to pay attention to. We have relative age dates. Okay, so that's relative. We know the sequence and order. And then the absolute dating is when we can actually put a date on it, the date that the president was assassinated for President Lincoln, for example. Okay, so we know when these things happen. All right, the law of superposition, however. With the law of superposition, this gives us the ability to tell how rocks were laid down. And it was originally developed by Nicholas Steno in 1669, so back in the day he noticed this. It's quite a while ago. And in an undeformed sequence of rocks, so what he's talking about, he looks at sedimentary rocks as they were laid down, and we look at their order. Okay, and then there may be some igneous rocks that poured down on top of it. Okay, so whatever the case may be, we know that the oldest rocks are always going to be at the bottom because things get built up. If you think about this, it's just like a deck of cards. If you take the cards and throw them up into the air and they land in a pile, you know which ones hit the ground first because it would be on the bottom of the pile. That's exactly what the law of superposition is. So I always think of it as a deck of cards that have fallen on the floor. All right, this is an example of superposition from the Grand Canyon. If we look at it, you can see that the oldest rocks are going to be down here, and our newest laid down sedimentary rocks are up here at the top. So you actually walk around on the newest rock when you go to the Grand Canyon to visit. The oldest stuff, when you look down, is way down in here, and we're able to see some of the oldest rock in the world here at the Grand Canyon because of the river has cut it down. You can see back in here the examples of what that sedimentary laydown looks like. It's very smooth. You can tell that there are different absolutely defined layers here. Okay, this gives you an example. At the very top we have the Caleb limestone, and to the very bottom you see the Supai group. Okay, so these are very much different rocks. They're composed differently. They were developed differently. Their colors are different. Grand Canyon is a great example of superposition. So this is what superposition is. Okay, as we look at the strata and the layer down of these rocks as they layer across. Okay. All right, another principle that you need to write down, and make sure you have this. And anytime I have things written and highlighted in red, you want to pay attention to these carefully. We have the principle of horizontality. And these are the layers of sediment that are generally deposited in a horizontal position. So just like when we talk down with superposition, we're talking about the layers that are laid down. This is horizontality. Rocks, layers that lay flat and have been disturbed, can also be this way. So we might find them where they are laid down, but they got pushed up at an angle. Does it make any different than this? No, it's the same stuff, same kind of rocks that are laid up. but the horizontality is the same. So this is what we're referring to when we talk about that, is that horizontality. Okay. The principle of cross-cutting relationship. This features rocks that have cross-cut into older features. So let's say, for example, we have our horizontality here, and we end up with a cross-cutting with this rock that goes across the middle. Okay, and this may be a lava flow that pushed in here or a dike that went in. So this would be our cross-cutting example. They can also be at an angle. Same situation happens here. Okay, different rocks that are moved. So you see these two different examples. Okay. All right, cross-cutting, of course, here's an example of that cross-cutting. I talked about the dike earlier, where you have our layers that are laid down over time, something pushed in here. But then all of a sudden you see that there will be this volcanic action that pushed in, and you can see where that leaked across. We call these dikes. Okay, and dikes are what we use. You can also see how this, in the real picture, we get the shift. There may be an earthquake at some point that shifted the limestone across, and everything's not perfectly lined up, but we still have that cross-cutting happening where you can see where they used to be, where they lined up, how these would have connected. Okay. And then here, of course, is an example of the real-life dike pushing in. Okay. All right, relative dating. Let's talk about relative dating in more detail. All right, the principle of relative dating is inclusion. It's an inclusion of a piece of rock that is enclosed within another rock. This is what inclusion is. Okay, make sure you have that written down. Rock containing the inclusion is younger. So inclusion rocks are usually younger rocks. So we saw that we had the cross-cutting occurring, and then we had the dike that pushed in. That dike pushed in, this is an inclusion. Okay, you see how that works. And then unconformity. An unconformity is a break in the rock or the record. So we have that rock. You saw how that they misaligned, and then they were down like this, off on each other. Get the fourth one. The record produced an erosion and non-deposited rocks. Let me show you an example. We'll come back to those. Unconformities have angle unconformity or tilted rocks. Disconformity. These are strata that are either on the side or unconformity or parallel. And then nonconformity, which is metamorphic or igneous rocks in contact with sedimentary rocks. Now, what does all this mean? Let's take a look at some pictures. And I would encourage you in your notes to take down these key terms, write their definitions, and then attach these pictures to them. Okay, you have your deposition, and of course the way, if we look back in time and we think about it, these are the earliest dates. Rocks were laid down sedimentary. Okay, we lay the rock down, the water is on top, or the ocean. Through time, we may have a volcanic upswell. You can see how this would push up, and we end up with this uplift that occurs, and that's uplifting and folding, and it actually makes the rock fold. Over time, then what happens is the winds and the water come through and they erode the top, and we end up where you can see where the mountain used to be here, or the hill, and then it got eroded down into this little valley. Okay, so we still have the same cross-cutting here going on, the unconformities happening, but then this is cut away, so the record is broke. Okay. Then, of course, later, back in time, we end up with the sea pushes back in, and then we end up with this new layers of being put down with the sedimentary rock. Now, you can normally look at these pictures. When you look at these, you can always tell where the unconformities are because they end up with this wiggled line in there, and that's really a hint. So normally when you see an unconformity, that equals this wiggled line, okay, on your maps. That's an important key when you start looking at these different kind of maps. All right, here's an example. You can see where the disconformities occur, or the unconformities. They've got the lines wiggled in there again. And we talk about the time frame of the Earth. This is the example of that picture, the real-life picture. Here's the diagram. And we can see, again, all the nonconformities again occurring right here in the Grand Canyon. Okay. Now, this shows the different periods of time, which we will study more closely with this being the Jurassic period, Permian, the Devonian, Cambrian, Precambrian. Okay, and this being the oldest period of time in Earth, this being the most recent, at least on this situation here. Okay. All right, guys. So there's some important principles that we want to remember. We want to remember horizontality. Okay. Unconformities. I think I spelled those right. What else do we have? We have the law of superposition. Okay, so these are some key principles that we want to keep in mind, all based on the theory that we originally looked at in uniformitarianism. Okay, so this stuff is all linked to our understanding of uniformitarianism, which builds these principles of what we understand in geology. The relative dating comes in when we look at these relative pasts. Okay, if we go back, we know that these are time periods. These are relative dating. This is a relative time that these things were laid down, and that's how they're connected. All right, this is part one. Okay, there's some assignments that'll go with this so you get an idea of what these are. And then from here, we're going to move on to part two, and we'll talk about some other of these major principles. All right, see you later.